Hello, my name is Christopher Cook, and today we'll be performing a code review on my final project from IT312, the dice game Left, Center, Right. Today we will cover the code's existing functionality. We'll do an analysis upon that code, and then we'll take a peek at our planned enhancements for this term. Starting here, we'll go over to GitHub, and we will go through all these different files. Now, some of these are just built-in Visual Studio things, but the main function is located within ccooke final project LCR. This naming format comes from me making the Visual Studio project called that itself, so it had created my main class file with that same format. Looking here, it's real simple. We load the game and we run the game. Now, some of these other includes are to make sure that we have these headers within scope at this point in time. Now, all of these header files are utilized within this, but we'll start by looking at the game loop class file, and then we'll go and look at the individual headers and some of the included text files. So going over to game loop, we see that include a number of other things here for us to utilize. It comes with the ability to output a file. We use that to display the rules to the player and display the title screen to the player. It has a menu it displays, the ability to grab some user input, and it has this perform action function, which used to be much bigger. This was built off of another project, and I was slowly working to step away from this. You'll see it actually really only prompts for the player count now at this point, which makes it kind of a pointless switch case. But I digress. We're able to check for a player win. Instead of returning a -1 here, that's a magic number, something we'll see over here in this list, that we really should have returned constant invalid. These probably should have been class level scope variables, global variables, instead of just within the scope of this function here. Moving on, I gotta grab a battery charger, excuse me. Forgive the interruption. Moving on, we'll be looking at run game, which again was the main function call located within the main function itself. This is our main game loop here. We make some declarations up top and display the title screen, and pause for a moment just for it's a user experience thing. I felt it played better like that. We start by displaying the menu to the user after that and getting input on what they want to do with that menu. They can either display the rules or play the game. We check for invalid selections. Again, we have another magic number here which shouldn't have been used. We probably could have made 1 and 2, the string representations of those, into something else, or we could have, pulled the user input as an integer or cast it to an integer. There's a number of ways we probably could have approached that other than that. Then we move into the game action where we prompt the player count. This game requires at least 3 players. So you'll see we keep asking the user for the player count until they give us a valid number. Proper use of constants there. Clear the screen and create that many players. Then we set up their starting chips and initialize the dice. You see that we seed the dice so that it plays uniquely every time, our random number generator there. We figure out how many chips is needed for a player to win. And our first time running check win, or winning player index will come out to invalid, again -1. And then this is really where the gameplay begins, right here. So we start by iterating through all the players. We figure out how many chips they have, as this is relevant to how many dice they get to roll. And we print out the scoreboard so they're familiar where they're at within the scoreboard. Following this, we prompt them to roll the dice, roll and output the results for each dice. It does convert this over to, wish I had a slider here. Oh, it's right up above me here. Get last converted roll. Seeing as integers in this game don't provide the most of value, we could have used integers here to figure out where things go. Instead, we converted it over to actual dice values like it would be in real life, L, C, R, or asterisk. Nothing happens when the user gets an asterisk. And then we output the footer, and then we just kind of like wrap up. We have brackets around the player's turn. We flush things out and check if we have a winning player. If we don't have a winning player, we move on to the next player, and we continue iterating through all the players until we have a winner, at which point in time we output the game over text, which is just some ASCII art. We announce the winning player, followed by that ASCII art again, so it kind of frames around it. We pause, and then we clear the screen, at which point the console will prompt the player to hit any button to close the application. Now, we can go in and look at some of these header files here. We'll start with the game loop header file itself. Some of those functions should look real familiar. We just went over those, displaying rules and title and menu and prompting input and performing actions and checking win. And publicly available, we have the run game function. Now, game actions are just enumerators. Prompt player count, read rules. You'll notice read rules wasn't used. Again, as we work to step away from that sort of pattern. The player, though, looking in here, it's pretty self-explanatory, so it's not littered with comments. The player has a name and a chip count. We have getters and setters for that name and chip count, and then in case we want to do more complex math, we're able to add and remove chips in bulk. So if we know we want to add 3 chips to the player, we don't have to get their chip count and add 3 to that and then set chips. We're able to just say, hey, give them 3 chips or take away from them 3 chips. We can look at the dice here. The die knows the last roll that it had, which is just reflected as an integer. We define the number of sides on a dice. We're able to seed the randomizer. Roll a dice. You see here that we do convert the roll 1 to 6 instead of 0 to 5. We're able to return that last roll, or instead what we end up doing is getting the converted last roll, which will give us dice values more appropriate to the game. So we've looked at die and game actions and the game loop and the player. We can see some of these included text files. Our little game over splash, this will happen above and below the output for which player won. We display the rules. I'm not going to go through and read this. This would be a great time if you're unfamiliar with the game to pause the video and kind of review the rules for the game. As well, you could execute the application and choose on the main menu to display the rules. Over title screen, a little bit more ASCII splash, just LCR. A pattern from the previous instructor was to have general includes in this std.afx file. This is for the sleep functionality, whether you're on Windows or Unix. All right. So that kind of covers the existing functionality within it. The code analysis was largely performed there with it, but we'll kind of go through this checklist here for a minute. We don't have the design from last semester. It hasn't been included in a part of this review. But I think it suffices that this does correctly implement the design. I got a pretty good grade on this assignment. It functions very well through the UI. It conforms to pertinent coding standards. You'll see the game files here all follow the C++ naming conventions. Blah. We have good formatting and curly braces, following the way most people do in C++. There aren't any leftover stubs or test routines in the code, or unneeded procedures or unreachable code. C++ is a very explicit language, and Visual Studio is pretty powerful. Lets me know when things aren't being utilized. As well, that most of the testing for this was UI testing. There was no test-driven development or unit tests included with this. Can code be replaced by calls to external or reusable components or library functions? I think in some instances, yes. Looking back at the game loop here, a lot of I/O is handled, input and output is handled here within this file. We probably could have moved that out into its own class. You know, a single responsibility kind of thing. We maybe even could have made two classes, one for input, one for output, and had like an I/O manager that, you know, combined the use of both. Largely, there's no repeated code. Things are pretty modular. The responsibilities split between the idea of a player and a game loop, and, you know, dice and game actions, though game actions isn't used as strong as it could. For good reason, we're moving away from that. Are symbolics rather than magic number constants or string constants? For the most part, yes, though we did identify a couple of places where that does not take place. So that should be fixed up. Are any modules excessively complex and should be restructured or split into multiple routines? Yes, you know, so if we come over here and we look at the run game function, it runs from line 84 all the way down to 254. So, I mean, that's a pretty large and hefty function. A lot of this should be cut out into its own smaller, more bite-sized pieces. As part of our planned improvement, this should largely all disappear into individual states to be used within a state machine. We have a fair bit of documentation. A lot of it is self-documenting, I would say. It's pretty easy to read, but we do have notes in other places. I would say that the for each player was kind of superfluous. You know, we didn't really need that. But other places seem to, you know, handle dice results works for this block. It kind of identifies to me that this could have been brought out into its own function, you know, and that function could have been called handle dice results. Would have eliminated the need for that comment, I believe. It's pretty straightforward on how we go through this. The comments are consistent with the code, though. They don't identify that they're doing anything that we're not doing. Variables are all properly defined with meaningful, consistent, and clear names. You'll notice we don't have anything like temp or data. You know, we have longer names such as receiving player index, winning chip count, things along those lines. There are no redundant or unused variables. Again, C++ is a compiled language. The Visual Studio editor is, or IDE is pretty powerful. It would identify if there were any unused variables or anything along those types. Same thing with proper type consistency and casting. We don't do any casting, and everything's type is explicitly defined within the language that we're working within. We do avoid comparing floating point numbers for equality. We actually don't use floating point numbers at all, which allows us to not even worry about preventing rounding errors, because again, we work with integers and maybe a couple of strings. The code does avoid additions and subtractions on numbers with greatly different magnitudes by working within a very small set of magnitudes, 1 to 6, and there's no division within the project as well, so we don't have to test for zero or noise. Loops are very well written. I like to think that that's something that I'm pretty good at here. They're in the right place scope-wise and nested well. We don't have any infinite loop type cases or anything like that. Are the most common cases tested first in if-else setups? I would say yes. More common than not, the player will have a turn. So we evaluate that first, then others. I'm not sure that I actually had identified an if statement that contained multiple evaluations within the if statement itself, so that we could have used the correct one first. I'll be sure to look some more for that, but I don't believe there are any examples like that within this code base here. Moving on, so we're in loops, branches, if else. So we do have else and default clauses that allow us to ensure that we're covering all the cases. Every case statement does have a default, I'm pretty sure. And then we used one right down here. You'll see that we just break out of the loop if an existing case didn't take place. What that allows to happen is that the user retains their chips. They don't pass them to the left, right, or center pod. Loops are always terminable, or at least it's clear how. I suppose prompting for the player count could technically take forever, right, if they always keep entering an invalid player count. But we catch that, we inform them, we clear everything out and prompt them again, to keep trying. Our indexes and subscripts properly initialized just prior to the loop. We use for loops for things where we know the length of them. And while loops have a flag that gets manipulated within here, that would be this player count gets manipulated and perform action when it's passed by reference, and blah. It didn't get initialized beforehand because it's used more than within that loop. The player count is a long running kind of flag. We'll use that later on down here. We had seen player index, player count, things like that. Our index and subscripts, we just did that. So can any statements that are enclosed within loops be placed outside of the loops? I don't think so, not at all. The only things we do within loops are things that need to take place within loops. Otherwise, it just would have been written right in line. Does code in the loop avoid manipulating the index variable or using it upon exit from the loop? Does the code in the loop avoid manipulating the index variable or using it upon exit from the loop? Well, so player count does get used throughout it, and we kind of did use that as a flag, but it wouldn't be the index. And for the for loops, due to being out of scope, it would be impossible to use the index outside of the loop due to the nature of the language and environment that we're working within here. It just wouldn't compile. Defensive programming. Are indexes, pointers, subscripts tested against array, record, or file bounds? We do store those properties as part of objects, and that's used as part of the for loop there. I don't know what it means here by imported data tested for validity and completeness. If that's from, say, like the user input, we do perform checks like that. So are all output variables assigned? I'm not sure what's intended there. Is the correct data operated on in each statement? Yes, the correct data is operated on in each statement. Is every memory allocation deallocated? No. We do, I believe, dynamically allocate the array of players, and that deallocation, I've noticed, does not take place. So we got run game here. Sort of we gather the player count, and then here we're dynamically allocating an array of players. Players should be a pointer object set at the top of run game within that scope. Yeah, players. We did not deallocate. We should have deallocated that memory. Are timeouts or air traps used for external device accesses? I have no idea. Are files checked for existence before attempting to access them? So we can go peer to output file where we do access files, and we can check and make sure. Yep. So we do create this. Is open would not happen if the file did not exist. And we'd get this output here that we're unable to locate the file. And are all files and devices left in correct state upon program termination? So if we were writing to files or something like that, that would be a concern, but currently we do not write anywhere. So I don't think that's a concern we have here within this program. So we've done a bit of a code analysis after looking at the existing functionality. Now we need to look at the planned enhancements for this program. So to start with, run game is going to change its pattern. It's going to move from this big wall of text to a state machine. That state machine, each state will have an idea of what state runs after itself. They'll maybe have to do some small checks. And then so this will just be a loop where it's pretty much while state does not equal game over, continue executing the state with each state setting up the next state in the state machine. This should vastly improve readability, modularity, maintenance. It'll be a good thing for this to happen. Secondly, we're going to step away from a bounded players list here that we understand both the start and the end of. As part of the algorithm that we're going to be implementing here, or data structure, would be that players are going to become a linked list. This will work nicely with the state machine, and that every time it's time for a new player's state to take place, we could just grab, the next player from the linked list and not actually care about how many players there are. That could be 3, 50, 100, it doesn't matter. We won't have any need to know about the player count outside of the initial setup. Lastly, it's time that this does get a chance to do some output. So our last planned enhancement would be to have a small leaderboard. You'll notice here in this run game that we did not actually gather player names. I guess that goes back over to this code review here, that unused stuff, and we didn't use player names. I'm seeing that now, but that'll work well with the database. That'll remain until that point in time, at which point we'll work on prompting the player for their names, and then we'll save player scores in the database, how many chips they won with, as that's a good indicator of how well of a game you've had. You can win with 1 chip, or you can win with 9 chips, assuming a 3-player game. I think it means more when you win a game with more players too, and a game with more players would likely end with a much higher winning chip count. So that is our code review for today. We'll go back over this here, make sure that we didn't miss anything, but I'm thinking we got it all. Yep, so we talked about our software engineering and design. That would be the state machine and different game states, the algorithms and data structure, how we're going to move away from the existing player pattern into the linked list of players, And then the database connection lastly, where we'll use the player names to kind of keep track of like high scores and things like that. You know, maybe how many games you've won as well. So, well, thank you for watching. I look forward to finishing this.